set of instruction that's given to the computer or processor. That means the microprocessors are able to understand only the instruction set. If I go with microprocessor, here microprocessor is also responsible for performing different kinds of roles. All the data which is stored in the computer memories are expressed in terms of bytes. Hello to all, a warm welcome to my new session on Anatomy of Computer. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, you may thinking, what is this anatomy of computer? Anyway, dear student, we are going to study in depth about the component of computer. So dear student, I am going to start with the topic that is functions of a computer. Along with that, I am going to deal with microprocessor, storage unit. Along with that, I am going to deal with how to execute a program in the CPU. Along with that, what is microcontroller? Along with that, I'm going to deal with difference between microprocessor as well as microcomputer. Anyway, dear student, let's start with the functions of a computer. So what is the function of computer? So dear student, think that I'm going to feed the data. So I'm going to enter some data to the computer. So what is my first function? That is, data is entered into computer using input device. For example, I want to type hello. So what I will do? I will type hello from the keyboard. Now, after that, whatever the data I typed, that must be stored in the computer. Now, let me to consider computer memory. For example, say this is computer memory and the size of the each block is 1 byte. So, I am going to store HELLO. So what is the second job of computer here is that whatever the data or instruction I'm going to provide, first it's going to store the data in the memory, then process. Process means what? Execute or use them as when required. So first, whatever the data I'm going to enter, that must be stored in the computer memory. Now, see, this data is stored in the computer memory, and if that data is required by the user, then it is processed. Now, what is my third functionality here? Data is processed. So, whatever the data I entered, that is processed and converted into meaningful information. Then output is generated as per format. So after processing data, what I'm going to get? I'm going to get the output. So output is generated based on the format. That means whatever the format I'm going to specify, based on that output is generated. And a control mechanism is established for controlling all the functionality. So a control mechanism is established for controlling all the functions. Now, who is the job of controlling all the flow? That is CPU. So here CPU is responsible for controlling all the operations, performing all the operations. All those things are done by the CPU, and these are the functions of a computer. Moving further, I'm going to have microprocessor. So dear student, what is this microprocessor? Where this microprocessor is present? Before that, let me to ask what is CPU. If I ask the question what is CPU, the answer here is the black box. Is it CPU? No. Most of the answer is the black box which I'm going to have with my computer. So the answer here is it is wrong, because whatever the box I'm going to have, that is not the CPU. So what is CPU here? That is placed with the motherboard. So whatever the processor, whatever the microprocessor, it is coming with the motherboard as CPU. So dear student, the motherboard itself CPU, and the motherboard with the processor is known as microprocessor. Processor is itself known as microprocessor. So a microprocessor is a controlling unit. That means all the works which is carried out by the computer system, as well as coordinating all the input device, all the output device, are done by the controlling unit. And which controlling unit? That is CPU. CPU is nothing but the microprocessor. So here CPU is nothing but the microprocessor. A microprocessor is a controlling unit of a microcomputer. If I consider any microcomputer or laptop or desktop system, then the controlling unit is microprocessor, which is fabricated on a small chip. So which is fabricated on a small chip and responsible for performing all the arithmetic operations as well as communicating with all the devices. Also, it is responsible for controlling, coordinating all the devices which is connected to the computer system. So what is microprocessor here? That's nothing but the small chip, or it's a controlling unit responsible for controlling as well as coordinating all the input devices as well as output devices. So here microprocessor consists of ALU, register array, and a control unit. So here microprocessors are made up of ALU, that is arithmetic and logic unit, along with that control unit, along with that register. So it is none other than CPU. So what is microprocessor? That is nothing but the CPU. So here ALU is responsible for performing all the arithmetic operations like addition, subtraction, multiplication as well as division. At the same time, it is also responsible for performing all the logical operations like and, or, not. Along with that, it's also responsible for performing all the relational operations like greater than, less than, or equal, etc. Now, register array. So, what is register? Registers are the intermediate storage. That means registers are used to store intermediate result. And when I talk about register, I'm going to have special purpose register as well as general purpose register. And I'm going to have 16 general purpose register, along with that 5 special purpose register. So a register array consists of registers identified by the letters like B, C, D, E, H, L, and accumulator. And control unit is also responsible for controls the flow of data as well as instructions within the computer. So these are the job of ALU as well as register as well as control unit. So in general, what is microprocessor? It's a controlling unit that is fabricated on a small single chip. Now, I'm going to have the list of terms used in a microprocessor. So here at the beginning, I'm going to have instruction set. Now, what is this instruction set? Before that, tell me what is instruction. Before that, tell me the difference between data and instruction. So, what is data? Data is nothing but the unprocessed item. Data is nothing but the raw fact. Then what about instruction? Here instructions are nothing but the processed data. That means that gives some meaningful information to the user. Then what about instruction set? Why I required instruction set? Because as we know that the computers are dummy machine. Suppose if I want to get any work done by the computer system, then I want to provide the instruction. For that, I required instruction set. So, it is the set of instruction that the microprocessor can understand. So, here, what is instruction set? That is nothing but the set of instruction that's given to the computer or processor. That means the microprocessors are able to understand only the instruction set. Then what about bandwidth? The number of bits processed in a single instruction. So when I consider instruction, I have data. That is nothing but it's represented in terms of bits or bytes. Now, if I consider bandwidth, it is the number of bits processed in a single instruction. Along with that, I'm going to have clock speed. So why I required clock speed? There's nothing but the execution speed. So it determines the number of operation or number of instruction executed per second. So it is mainly used to determine the number of operations per second the processor can able to perform, and it is expressed in terms of megahertz, gigahertz, or it's also known as clock rate. That means the number of instruction executed per second or per minute. So it is nothing but the clock speed. Moving further, I'm going to have word length. So what is this word length? It depends upon the width of internal data bus. So dear student, when I talk about register, as I told, we have some special purpose register that is nothing but memory address register, memory data register, counter, instruction pointer, as well as accumulator. Then here the job of the data register, that is memory address register or memory data register. So here I'm having data bus. Now this data bus is responsible for carrying data from one device to another. So it depends on the bandwidth of internal data bus. Now I'm going to have internal data bus as well as register as well as ALU. And if I consider microprocessor, 8-bit microprocessor can able to have 8 bit of data at a time. And the word length ranges from 4-bit to 64-bit. Now, based on the microprocessor, that means size of the microprocessor, I'm going to have the word length. For example, if I have 8-bit microprocessor, then it can able to transfer or carry 8 bit of data at a time, and The word length ranges from 4-bit to 64 bits depending on the type of microcomputer. So the word length varies depending on the microcomputer. Then I'm going to have data types. The microcomputer or microprocessor has multiple data types. So here it is not like C programming data type, because computer understands only machine instruction, and how I'm going to provide the instruction to the computer in the form of machine language, because computer understands only machine language. Then what kind of data type I can able to have here? That is binary coded decimal, ASCII, signed or unsigned number along with that binary numbers, because computer understands only binary value, that is 0 and 1s. That's nothing but machine language. Now I'm going to have features of a microprocessor. So what are the features of microprocessor? That is cost effective. So the microprocessor chips are available at a low price and results its low cost. That means nowadays most of the manufacturing companies are going to manufacturing microprocessor. So the cost of the microprocessor chip is very low and it is cost effective. Size. The microprocessor is of small size chip, hence it is portable. So what is microprocessor here? The name itself indicates that it is micro. That means the size of the chip is very small and we can able to carry from one place to another place very easily, because it is a small chip. For that reason it is portable. And low power consumption. That means the microprocessors are going to consume very less power. So here microprocessors are manufactured by using metal coaxial semiconductor technology. So here all the microprocessors are manufactured by using metal oxide semiconductor technology. It consumes very less power. Along with that, I'm going to have versatility. So what is this versatility? The microprocessor are versatile as we can use the same chip in number of applications. So versatile means what? Capable to perform more tasks or different tasks. So generally we are going to tell versatile actor. That means one actor is performing different roles. Similarly, if I go with microprocessor, here microprocessor is also responsible for performing different kinds of roles. For that reason, it is called versatile. So here we can use same microchip in a number of application. That means different application can able to make use of single chip or single microprocessor. And what I have to do here, I just want to configure the program. That means for single chip I can able to install many application software or many software. Now I'm going to have reliability. The failure rate of IC, that is integrated circuit in a microprocessor, is very low and hence it is reliable. That means here microprocessors are made by using integrated circuit. If I consider integrated circuit, the failure rate of integrated circuit is very low. For that reason, microprocessors are reliable. Now I'm going to have storage unit. So what is the storage unit? That means how I can able to store the data in the computer memory. So here memory unit is the amount of data that can be stored in the storage unit. So dear student, if I consider computer memory, okay, it is classified into two types, primary memory and secondary memory. When I have very small amount of data, then I can go with primary memory. When I have bulk amount of data, then I can able to go with secondary memory. And how I'm going to store the data in the memory, in which form or in which format is known as units. So here memory unit is the amount of data that can be stored in the computer storage unit, and this storage capacity is expressed in terms of bytes. That means all the data which is stored in the computer memories are expressed in terms of bytes. And if I consider byte, there is nothing but 8-bit. So what is this bit? There is nothing but 0 and 1, because computer understands only machine language, and whatever the data we are going to provide to the computer, that is in the form of 0 and 1. So here 0 and 1 together known as bit. That means 1 bit indicates 0 or 1. I can able to have 0 or I can able to have 1. So here the following table explains the main memory storage unit. So this is the storage unit of a main memory. First, I'm going to have bit. That's nothing but binary digit. A binary digit is logical 0 and 1. So here bit is nothing but 0 and 1. And listen here that 0 is always low or false, and 1 is nothing but high or true. So here 0 is used to indicate low signal or low voltage, and high is used to indicate high signal or true signal. That means 1 is used to indicate high voltage or high signal. So a binary digit is logical 0 and 1, representing a passive or active state. Passive means what? Inactive state, that is 0 state. Active state means what? It is 1 of a computer in an electronic circuit. So here 0 is nothing but low signal or low voltage, and 1 is nothing but high signal or high voltage or true value. Now I'm going to have my next storage unit, nibble. So what is this nibble? That is group of 4 bits. For example, if I have 1010, it is 4 bits, right? So it is called nibble. So group of 4 bits. So a group of 4 bit together called nibbles. And followed by, I'm going to have byte. So what is this byte? A group of 8 bits is called byte. A byte is the smallest unit which can represent a data item or a character. So what is byte here? Here byte is nothing but 8 bits. When I have 8 bit, then it is termed as byte. 8 bit by 1 byte. So what is bit here? That is 0 or 1. I can able to have all 8 zeros or all 8 ones or combination of zeros and ones. That means I have 8 combination of zeros and ones. So word. So what is word? In a computer, word is like a byte. It is a group of fixed number of bits processed as a unit which varies from computer to computer, but it is fixed for each computer. Word. So one word means what? 2 byte. When I have 2 byte, it is termed as word. So what is this 2 byte? It is nothing but 16 bits. Okay. Now 16 bit, 2 byte. So what is 2 byte? It is one word. So a computer word like a byte, it is a group of fixed number. When I say it is word, it is nothing but the group of fixed number. Fixed number is nothing but the bits, and which is going to vary computer to computer, but fixed for each computer. That means word is going to vary from one computer to one computer, but it is fixed for each computer. And the length of a computer word is called word size. So the length of the computer word is called word size or word length. It may be small as 8 bits or long as 96 bits. A computer stores the information in the form of computer words. So when I talk about words, the smallest word length I can able to have here is 8 bits or 1 byte, and largest size here is 96 bits. So dear student, followed by storage units, I am going to have how CPU, that is central processing unit, and memory works. That means how the CPU and computer memory works. So here CPU. What is the job of the CPU? Executes program using fetch, decode, execute cycle. So here CPU is responsible for fetching the data. After that, decode the data. After decoding, execute the data. Fetching means what? Reading or accessing data. Then decode that data, execute that data. Then if I consider memory, stores program, operations and data while a program is being executed. So here memory, that is nothing but main memory or primary memory is responsible for storing the program as well as data while that program is being executed. There are several types of memory including register, cache, RAM and virtual memory. So all these things are related to main memory. Now if I go with storage, so here storage is nothing but always secondary storage device. It stores the data and files long term. That means if I want to store the data for longer use, then I can go with storage unit even when they are not in use. That means whatever the data I'm going to store in my secondary storage, I'm not going to use that one for time being. That means I'm going to use the data after long time. In that situation, I can go with storage. So here devices such as hard disk, USB memory stick or SD cards are used to store the files such as photos, music as well as software applications long time. So which are the example for storage? That is hard disk, floppy disk, magnetic tape or optical disk. These are the example for storage. Now I'm going to have how the program is executed in the CPU. So here I'm going to have this sequence. That means I'm going to have this step. How the program executes in the CPU. So a sequence of instruction is stored in the memory. How the instructions are stored? Sequence. So, sequence of instructions are stored in the computer memory and each memory has address. Wherever the first instruction is found is copied to the instruction pointer. So, dear student, here we are going to encounter the topic called register. So what is register? It is mainly used to store intermediate result. And example for register, here I am having instruction pointer, that is IP, program counter, that is PC, memory address register, memory data register, and I am going to have accumulator. And to execute any program, I required all this register. Now, the memory address, wherever the first instruction is found, that is copied to the instruction register, that is instruction pointer. So here instruction pointer is nothing but the special purpose register. And the CPU sends the address within the instruction pointer to the memory on the address bus. Now, the job of the CPU is to send the address which is stored in the instruction pointer to the memory on the address bus. For that, I am going to have memory address register. Now, the CPU sends a read signal to the control bus. Now, the job of the CPU is to send the read signal to the control bus. Now, memory responds by sending a copy of the state of the bits at the memory location. So, here memory, that is computer memory, responds by sending copy of the state of the bit. So, it is going to send the copy of the state of the bit at the memory location on the data bus that the CPU then copy into its instruction register. So, here the memory responds by sending a copy of the state of the bit. So, it is going to send the state of the bit and where the data is present. Now, the data bus is responsible for sending the data so that CPU can able to copy that into its instruction register. So, here the instruction register or instruction pointer is automatically incremented to contain the address of next instruction. So, here the instruction pointer is automatically going to incremented to contain the address of the next instruction in the memory, and CPU execute the instruction within the instruction register. Now, the job of the CPU is to execute instruction that is within the instruction register. Then go to the step 3, step 4 and step 5 are called to fetch the instruction. So here from step 3 to step 8 it is continuous cycle. So it is known as instruction execution cycle, and I'm going to have the pictorial representation. So here what is the job of the CPU? Is to fetch the data. So fetch the instruction pointed by the instruction pointer. So dear student, what is my first step here? The sequence of instructions are stored in the memory. Okay, the memory address are copied to the instruction pointer. For example, say this is the memory. Okay, so I have typed 11 and it is stored at the position, say memory address 1000. Okay, now see here, memory address, wherever the first instruction is found, that is copied to the instruction pointer. Now see here, at the location 1000 I have content 11. Now what is the address of IP instruction pointer? It is 1000. Now fetch the instruction pointed by the instruction pointer. Now the job of the CPU is to fetch the data which is stored in the memory address, and where I'm going to get the memory address from the instruction pointer. Now add number of bytes in the instruction to the instruction pointer. So after fetching, the IP, that is instruction pointer, is incremented to fetch the next data. Add the number of bytes in the instruction to instruction pointer. So after fetching, what I'm going to do, or what is the job of the CPU, is to execute the instruction. And the fetched data is only half. Then what I want to do? I want to go to the instruction pointer once again to get my next half of the data or instruction. And if all the instructions are fetched, then if that condition is true, then I'm going to stop the execution. This is the way the program execution in the CPU is going to carried out. Now I'm going to have microcontroller. So what is this microcontroller? Anyway, dear student, we know what is microprocessor. So here microprocessor is nothing but the small chip or smallest unit, and it is responsible for performing all the operations. So here microprocessor is nothing but CPU. But what about microcontroller? So dear student, a microcontroller is a small and low cost microcomputer. So here microcontroller is also small and low cost microcomputer which is designed to perform specific task. So microcontroller means what? It's mainly designed to perform specific task which is embedded with the system. Example, displaying microwaves information, receiving remote signal, etc. So here microcontroller is also smallest unit and it is embedded with the microcomputer, and it is responsible for specific, that means it is responsible for performing specific tasks like displaying microwave information or receiving remote signals, etc. So the general microcontroller consists of processor. So here the general microcontroller includes processor, Along with that, memory, that is RAM, ROM, EPROM. What is RAM? Random access memory, ROM, read-only memory, and what is EPROM? Erasable, programmable, read-only memory. Along with that, it's going to include serial ports. Along with that, it's going to include peripherals, that is nothing but timer as well as counter, etc. Now, dear student, let's see the difference between microprocessor as well as microcontroller. So, dear student, at the beginning, let me to explain what is microcontroller. So, a microcontroller are used to execute single or specific task within an application. So, it is mainly designed to perform specific task within the application, but microprocessors are used for big applications. The next difference here is to design microcontroller, it is very low. That means cost required to design microcontroller as well as hardware, the cost required is very low, but to designing and hardware required by the microprocessors are very high. Now, if I consider microprocessor, if there is any fault, then it is very easy to replace microcontroller. But if there is any fault with regarding microprocessor, then it is very difficult to replace. And if I go with microcontroller, it is built with CMOS technology. I repeat, it is mainly built with this CMOS technology, which requires very less power consumption. And if I go with microprocessor, its power consumption is high because it has to control the entire system. That means the power consumption is very high in microprocessor with respect to microcontroller because it has to control entire computer system. Now, if I go with microcontroller, it includes CPU, RAM, ROM, input-output port, and if I go with the microprocessor, it does not consist of RAM, ROM, input-output port. It uses its pin to interface to peripheral device. So, what is this peripheral device? That is nothing but the input and output device. To connect with our input device in our microprocessor, and we are going to have the pin. With the help of pin, we are going to get the interface. That means here we are going to use the pin as interface in order to connect it to the peripherals. So, what is peripherals here? That is nothing but the input device as well as output device. So, dear student, in my today's session, I started with what is microprocessor, the working procedure. Along with that, I have discussed what is microcontroller, how the programs are executed by the CPU. Along with that, I have completed difference between microcontroller as well as microprocessor. So, dear student, in my next session, I'm going to deal with the input device. So, until that, keep learning and keep watching. Thank you.